How are you, my friends? In this video, I'm presenting basic math terms, part 25, about linear and non-linear systems of equations. And these terms are coming from lectures 29 and 30 of the pre-calculus course. The linear system, non-linear system, substitution method, elimination method, inconsistent, infinitely many solutions, and the number of solutions and the intersection points of the graph. What is the relation between them? Please, you can check the other parts of this playlist, basic math terms, if you like. Now, what is a system here? Then we say, what is a linear system? A set of equations is called a system of equations. So you can have two equations, you can have 3, you can have 4, you can have 5, you can have 50. The solutions of a system must satisfy every equation. The solutions are the intersection points of the graph. We will see that at the last slide. If there is no intersection, there is no solution. See, this is a simple, easy example. We have two straight lines. They intersect in one point. Now, if the equations are linear, linear means the power on the x is 1. No square root, no squared, no degree 3, no fractions in the x. You can have fractions in the coefficients. So if the equations are linear, here the last line, then the system is called a linear system. So a linear system, all the equations should be linear equations. A non-linear system, we should have at least one equation not linear. See, here we can have a linear, 2x minus y is equal minus 16. That's a linear. But since we have a squared here, only one term, one equation, then we call the whole system non-linear. We cannot say this is linear and non-linear. All the system, either linear or non-linear or not linear. This one we have a squared in the x and the y. Here we have power, 5 to the power y. So all of these are non-linear systems. You can have logarithms, you can have square root, you can have whatever. In the non-linear system, you can use substitution, you can use elimination. It depends on the equation. And then you have to check your proposed solution in the original system, in every equation. In the linear system, you don't have to check. If you like, you can do it. Now let's look at two methods here. Elimination. Elimination, the most important word, the verb is eliminate. See, we eliminate one variable from the equation. We should have coefficients up and down, either x or y, the same number, but in the opposite sign. Let me show you, I think, an example. Yes, okay, good. Question number 1, solve the linear system by elimination. Here we have fractions, but these fractions are the coefficients. Still, we have x power 1, y power 1, y power 1, x power 1. Be careful in the arrangement here, x and y. So we don't care about these fractions. We can just multiply by LCD. Then we have to eliminate one fraction. Let's rearrange it and call this equation 1 and equation 2. See, this one, the y, I put it here, and then 1 over 3x, I put it at the beginning. You have to rearrange it. Line up all the x, line up all the y. Now, in the first equation, we have 4 and 2 in the denominators, so multiply by 4. Both sides, remember. See, when you multiply by 4, do not forget the 5. That will be 20 here. Here we have 3 and 3, multiply by 3. LCD will be 3. Also multiply by the minus 4, so it will be minus 12. So this is the given. This is after we rearrange equations 1 and 2. This is equations 3 and 4. Here we have 3x and x, so easy to multiply by minus 3 down. Minus 3, remember, minus 3 times 10, minus 3 times minus 12 will be 36. Now you add the equation. So this is eliminated, see? Cancelled, eliminated, deleted. So you will have 2y minus 30y minus 28y is equal 56. Y will be minus 2. Then you can take any equation you like to find x. From 3 and 4 may be easy. Take x will be minus 12. Take this on the other side, minus 10y. Y is minus 2, so x will be 8. So the solution will be x and y, remember, ordered pair, x and y. This is a nice example. Substitution method is another method of solving linear and non-linear systems. We have to choose either equation 1 or 2, solve for x or y, call this new equation star if you like, and then substitute. So the verb here is we substitute, we replace a quantity in another equation. Now, question number 2 says, solve the nonlinear system by the substitution method. In the substitution method, we take one equation and we solve for x or y, then we substitute in this second equation. So we have x plus square root of y is equal to 0, y squared minus 4x squared is equal to 12. You can find many nice questions about nonlinear systems in lecture number 30 of pre-calculus. Now, to use substitution in this question number 2, we take the easy equation, which is number 1. We solve for x. So x will be minus square root of y. Now let's square both sides here. We square this side, x squared. You square all of this. You see inside the bracket here, minus square root of y all squared. So x squared will be only y. Let's call this one star. You can call it equation 3 if you like. You can call it equation A or B or whatever. Now let's substitute star, this one here, x squared is equal to y, in the second equation. So we get y squared minus 4x squared. I put y is equal to 12. This is a quadratic equation. Rearrange it. Put everything on one side equal to 0. Factor it. Y plus 2, y minus 6 is equal to 0. Then we have two values for y. Y is equal minus 2 or y is equal to 6. Y minus 2 rejected, because if we put minus 2 here under the radical, it will be minus, so we cannot accept that. So y will be only 6. So y is 6. You can get x minus square root of the y, which is minus square root of 6. Now we have one solution here, but you have to check. Remember, in the nonlinear systems, always you have to check. So this x is minus square root of 6, and this is the y, only 6. Before we say this is the solution, you have to check it, which means replace x and y in both equations here in the nonlinear system, in both. So you have to put the x value plus the y, make sure this is 0. Put the y squared here, minus 4, the x squared is equal to 12. Yes, this is 36 minus 24 is equal to 12. So that's already yes. So the solution will be minus square root of 6 and 6. Now the meaning of inconsistent, this is very important word. Inconsistent, it means no solution. That means if we have simple linear system with two straight lines, we say no solution. When you graph it, the lines will be parallel. So there is no intersection point and no solution, and we say the system is inconsistent. You can use also this word in any system, linear or non-linear. Infinitely many solutions when we have the same equations, so they intersect in all points. So we say the system has infinitely many solutions. Now the number of solutions is the same as the intersection points. So when you use graphing method, you graph all the equations and then you look at the intersection points. So the number of solutions, if you need to count how many solutions, 2 solutions, 3 or 4 or 1 or none, the number of solutions equals the number of intersection points. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.